Hello, welcome back. Today, we're going to take a look at logarithms, and specifically, we're going to examine three rules involving logarithms. We're going to look at the product rule, the quotient rule, and the power rule. Okay, so let's take a look. Now, as you know, logarithms and exponents are inverse functions of each other. So the rules that govern exponents also are the rules that govern logarithms. So let's take a look at how that plays out. The product rule for logarithms goes like this. When you are taking the log base b of two things that are multiplied to each other, you can expand that to be the log base b of one of those things plus the log base b of the other of those things. This rule goes in the other direction as well. If you have the log base b of something plus the log of that same base b of something else, that can be simplified to the log base b of the first thing times the second thing. And you notice that rule sounds awfully familiar to the exponent rules. Next, we have the quotient rule. The quotient rule tells us that the log base b of two things that are dividing, m dividing by n, can be expanded to be the log of the numerator minus the log of the denominator. Division can be expanded into subtraction. And this rule goes the other way around. Subtraction can be simplified back to division. And finally, we have the power rule. The power rule says that the log base b of something raised to a power can be simplified by taking that power and swinging it around the front as multiplication. So the log base b of m to the k becomes k, that power, multiplied to the log base b of m. And you should note that these three rules are similar to the exponent rules, right? When we have x to the a times x to the b, that becomes x to the a plus b. The multiplication becomes addition. The multiplication becomes addition. Same thing here. When we have x to the a divided by x to the b, that becomes x to the a minus b. Division turns into subtraction. Division turns into subtraction. And then finally, when we have x to the a raised to the b, that becomes x to the a times b. Raising to a power turns into multiplication. So the log rules and the exponent rules share similarities. Okay, let's take a look at this in action. So here we have a problem, and the directions are expand. So we have the log base 3 of x to the third times y divided by z to the second. So let's take a look at how we would expand this. The first thing we're going to do is we see division here. So we're going to use our quotient rule. And so our quotient rule says that instead of division, we're going to take the log of our numerator minus the log of our denominator. So our first level of expansion becomes the log base 3 of x to the third times y, right? That's our numerator, minus the log base 3 of our denominator, z squared. All right, so now let's do this term first because it's just sort of a single term, whereas this we see multiplication. So here we have a power. So let's apply our power rule. So this part of things is minus that exponent swings to the front and becomes multiplication, log base 3 of z. And this term is now fully expanded. When we go back to this term, you might be tempted to do the same thing and take this 3 and pull it to the front. hold on, we will do that eventually, but y is not raised to the third, just x is. So if I pull the 3 to the front now, it's essentially applying it to the y also. So the first thing I have to do is separate these two multiplied terms. So I'm going to use my product rule, which says that the log of two things multiplied is the log of each of those things added to each other. So the log base 3 of x to the third times y is the log base 3 of x to the third plus the log base 3 of y. So now notice, I'm not saying that it's the log base 3 of x to the third plus y. I have to apply the log to each of the terms and add the logs of each of the terms. So just note that difference. This term is fully expanded, but here I still have a power, so I apply my power rule. And so my final bit of work here is 3 times log base 3 of x plus log base 3 of y minus 2 log base 3 of z, and that is my fully expanded version here. Now, let's take a look at applying these rules in the opposite direction. So this time I'm being asked to evaluate. And so that means you can see that I've got things strung out here, expanded. So now I'm going to do the opposite. I'm going to contract. Now, I want you to notice something. These say log base 3. These say log base 4. I can apply my rules to these two terms, and then I can apply my rules to these two terms, but I cannot apply the rules to two terms that have different bases. I can't put those guys together. So let's go ahead and start over here. Log base 4 of 32 plus log base 4 of 2. I see my plus there, and I know that a plus can turn into multiplication, the product rule. So I've got my log base 4 of, and the two logs I was adding can become multiplication. So the log base 4 of 32 times 2, or the log base 4 of 64. And now that should look familiar. So a little sidebar over here. Let's remember that when we have the log base b of x equals y, the exponential form of that is b to the y equals x. B to the y equals x. And if that is brand new information to you, pause and go take a look at my basic video on logarithms. But if this is something you've worked with before, then keep going. So if it's b to the y equals x is my exponential form, then I take a look here. 4 to the what equals 64. 4 to the what equals 64. And the answer to that question, 4 to the what is 64. 4 to the 3 equals 64. So the log base 4 of 64, all of that reduces down to just 3. All right, so that was that whole side. Now let's go ahead and work this side. All right, so log base 3 of 108 minus 2 log base 3 of 2. I see multiplication here, so that means I can turn that back into an exponent. So log base 3 of 108 minus log base 3 of 2 to the 2. Log base 3 of 108 minus the log base 3 of 4. 2 to the 2 is just 4. Now I see subtraction, and I know that subtraction can be rewritten as division. So that's the log base 3 of first term divided by second term, or the log base 3 of 27 And now I apply my same thing here. 3 to the what equals 27? 3 to the question mark equals 27. The answer to that is 3 to the 3 equals 27, which means, once again, log base 3 of 27 just equals 3. And so finally, 3 plus 3, this whole statement equals 6. Well done! So that was the product rule, the quotient rule, the power rule, and then how to expand using those rules and how to evaluate using those rules. Okay, great work. So do the video over again. Go take a look at the basic video on logarithms and keep an eye out for my next video on logarithms. And as always, keep mathing.